Okay, this is the lecture video for MAT 1100. We're in section 2.1, and in this section we're going to be taking a look at how to find the mean, which is the average, the median, and also the mode for a list of numbers. So we start off with the definition for mean, which again is the average, and to find the mean for a list of numbers, you add up all the elements that are in the list and then divide by the total number of elements. And we're going to take a look at that on the next page, how to do that. Okay, we also have the definition of median, and I wanted to mention that whenever you are doing the median, you have to put the numbers in order. In order to find the median. So you can list the data from the lowest number to the highest number. You could also do it the other way. But you have to put them in order to find the median properly. The median is the middle score, the score that's right in the middle. So if there is a number that's truly in the middle, and you see that we have two lists here, you can sometimes have the number that's right in the middle, and then sometimes you have to work with the two middle scores depending on how many elements there are in the set. Like for instance, notice that there are an even number of elements here. There's 4 numbers here. So when you have an even number of elements, you have to take the average or the mean of the two middle scores because there won't be an exact middle. See, if you were to say, oh, this is in the middle, that wouldn't be true because you have two elements on the left, but only one on the right. So that is not the exact middle. If you think this is the exact middle, same issue. You have 2 elements over here, but only 1 over here. And you should have equal number of elements on either side of whatever you're claiming is the middle. Now, when there are an odd number of elements, notice that there's 1, 2, 3, 4, 5 elements here. That's an odd number of elements. When you have an odd number of elements, you will have an exact middle. And you'll be able to find that exact middle score, which represents the median. You have to be able to find the middle score whenever you have an odd number of elements. So this is the middle here. Notice that there are 2 items on the right, 2 items on the left. So that is dead center in the middle, and therefore this score represents the median. Okay, again, the median score is the score that's right in the middle after the numbers have been put in order. Okay, again, coming back to this set of elements where we had an even number of elements. We had 4 elements here. There was no exact middle. So you have to go to the 2 scores that you were considering as the middle. That was these 2. And you have to find the mean, or what we call the average. So use both of these scores that are closest to the middle, add them up. You get 5. We just added up 2 scores, so divide by 2. Whenever you're finding a mean of 2 or more scores, you add them all up and then divide by how many you just added together. There were 2 scores here, so this came out to be 2.5. Okay, then as I said before, for the bottom set, the median was 3. So this represents the median for this set. This represents the median for the second set. Again, the median is just the middle score. Mode. Mode is the score that occurs the most often. And whenever you're talking about the mode for a set of numbers, your answer can either come out that there is no mode. Sometimes there is no score that occurs more often than the rest of the scores in the list. Sometimes there is just one mode. Just one number that occurs more often than the rest. And sometimes there are multiple modes, more than one. Okay, those are the three ways that your answer can potentially turn out. In this particular set of numbers, you have a list of numbers, 1, 2, and 3. There is no mode for this particular set of numbers because there's nothing here that occurs more often than the rest of the numbers. In this particular set, there's 2 modes. So multiple modes. And those numbers are the number 1, it occurs more often than the rest, but 2 occurs an equal number of times. So there we have 2 modes. Okay, so here we're just going over the mean. The mean is just adding up all the numbers and dividing by how many numbers, or you could call them elements, there were in the set. The median, you list the numbers from lowest to highest and then take the middle score. And then it talks about if there's an even number of data, an even number of elements, you're going to take the average of the 2 middle scores as I demonstrated up here. I'm going to give you a new list of numbers just so we can practice this again. And then the mode is the number or numbers, possibly, that occur most often. Okay, so here's another example that we can try. Let's say that we have let's say that we have these numbers in a list, and we want to do each of the 3 things that we've spoken about thus far. Let's say that we were going to do the average. If you're going to do the average, or what we call the mean, you would do the sum of all of these numbers. So you would add all of them up. And look at how many elements there are in the set. 1, 2, 3, 4, 5, 6, 7. There's 7 numbers in the set. So you're going to do the sum of all the numbers, and then you're going to divide by 7. I'll just put my work here. So adding up all these numbers. Okay, so we'd have 7. Just clear this screen out. 7 plus 12 plus 1 plus 23 plus 5 plus 7, and then plus 15 as the last number. Okay, I got 70, 1, 2, 3, 4, 5, 6, 7. Check the numbers, 7, 12, 1, 23, 5, 7, and 15. So my sum was 70. And I'm dividing by 7 numbers because there were 7 different elements in the set. And my final average, or my mean as it's called, you can name it by either one, but know both names, please, is 10. Okay, then if you're going to do the median, when you're doing the median, you have to put them in order. So I'm going to do that right here. Okay, so for the median, you would be putting all of these in order. So 1. Next biggest number is 5. And then we have a couple of 7s. And you might want to cross them out as you put them in order. So 1, 5, we did the 7s. Then we have a 12, a 15, and a 23. Okay, and then just kind of eyeball where you think the middle is And be sure to check that there are equal number of elements on either side of whatever you're claiming is the middle. So this looks like it's about dead center right here. Notice that if you count up how many elements there are to the right of where my pencil is, there's 1, 2, 3 elements over here, 1, 2, 3 elements to the left. So that 7 represents dead center, or what we call the middle score, mathematically known as the median. So the median is 7. So we didn't have to average the two together because there was actually a number right in the center. Then the mode for this particular set of numbers, there was something that occurred. There was a number that occurred more often than the other numbers, and that number was 7. Okay, so just an additional example so that you could see all three things being done for the same set of numbers. Okay, in section 2.2, we're going to be doing equations. And we're going to be solving equations with fractions. We're going to be solving equations where you're trying to bring both of your variables to the same side. All of these types of equations, and some equations will be 1 step, some will take 2 steps to get there, and so forth. So first let's, before we start looking at equations, let's talk about the different terminology that is used when you're building up to the concept of solving equations. Okay, first definition that we're going to be filling in for section 2.2 is, what is a letter that's used to represent a number in algebra? That is known as a variable. We typically use X, but you can use other letters from the alphabet. So we can use X, we can use A, we can use capital letters. Those are all examples of variables, but excuse me, when you're doing algebraic concepts, they represent numbers. Okay, a number in front of a variable, that is called a coefficient. So when I'm speaking to you about what I'm doing when I go to solve the equations, I'm going to be using all these words, and in order for you to follow what I'm doing, you should be, have a good working knowledge of what these words mean. So a coefficient is a number in front of a variable. So let's say you have the variable X, and you have the number -5 out in front. The -5 would represent the coefficient. Okay, if you have something like this, 1/4, and this is your variable, then the coefficient would be this fraction. So coefficient can be anything. It can just be, it can be a number, an integer, it could be a fraction, it can be a decimal. You might have something like this in front of a variable. Okay, so these are all examples of coefficients. Okay, a combination is variables and constants using mathematical operations and grouping symbols. So mathematical operators would be like plus signs, minus signs, multiplication signs, and typically when we're doing multiplication signs, we can use parentheses, or we can just put the variable right up against the coefficient, and that also indicates multiplication. Grouping symbols, so you're going to see different ways of representing multiplication. It could be a dot, it could be just a number right up against a variable, it could be parentheses like this. Grouping symbols are typically these, brackets when parentheses have already been used, and so forth. Okay, so what would be an example of a combination of variables and constants? Well, there's a name for it. First of all, it's called an expression. And an example of an expression could be the following. You could have 3x plus 2. What does this expression say? That x is being multiplied by 3, because when a number is right up against a variable, that is one way to indicate multiplication. And then there's the mathematical operator of addition, and you're adding a 2. That would be one example. You could have something like this. Okay, so that's an expression also. The expression x minus 5 is being multiplied by 7. So if you were going to try and solve an equation that had this expression in it, you would get rid of the parentheses by going 7x and then 7 times negative 5. This indicates multiplication that is going to happen repeatedly based on how many terms there are in the parentheses. That number is a multiplier of however many items are in this parenthesis. That would allow the parentheses to go away, and then you'd have a minus 4. And by allowing the parentheses to go away, by distributing or multiplying, you are then able to combine like terms. So you're going to see us getting into that. Okay, so you have a couple of examples here of what an expression is. Next definition, a statement that two quantities are equal, which is built using expressions and equal signs. S that we don't need. Okay, so this is called an equation. Okay, this would be an example of an equation. You could have something like this. You could have something like that, where you have an expression on one side. So you have a quantity or an expression here. You have a quantity here, and we're stating that these two quantities are equal. So this is an example of an equation. An equation with multiple variables, more than one variable. So far I've been giving you expressions and equations with just one variable, but if it turns into something like this, this would be what we call a formula. Notice that there's the variable a, but there's also the variable b and h. So when you're into multiple variables, it is called a formula, which are very typical when you're doing geometry problems. There are all kinds of formulas for doing area as well as volume. And we'll get into some of that as well. Not in this section, but in a section that's going to come later on in lesson 2.3, actually. Okay, so that's the various kind of terminology I'm going to be using as I discuss the rest of this section. Okay, one of the things that I want to be able to help you distinguish between is the independent and the dependent variable. There are different kinds of problems that involve independent and dependent variable when you go into ALEKS and when you take the test. And so I'm going to give you both types of problems. We can have problems that are worded like this. They come in sentence form, and you have to decide what's the independent variable and what's the dependent variable. So here are 3 examples of that type of problem. Okay, this would be one example, this is another example, and then this is the third example. I can also give you an example over here that's not in words, but you would still be expected to figure out what the independent and the dependent variable is. This is another word for independent variable, and the output is another word for dependent variable, because you can be asked this same question, which is the independent variable, which is the dependent variable, in problems like this. So we'll talk about this kind of question as well, and how do you determine what's independent and what's dependent. For these problems right here that are in words, I think the best way is to try and reword them, inserting the word depends in between the two variables. Variables are things that can change. Variables are the quantities that are changing. And they represent variable quantities that change. Okay, so first thing you're going to want to do when you're doing these problems that come at you in words is to identify what are the variables. So in this particular problem, this is a variable because age can change. As you see in people, as you see in things in nature, animals, plants, all of those things. So we have this as a variable, and also our height changes. I mean, up to a particular point. We don't continue growing in height our whole life. So this is also a variable. I think you should take those two variables and try to insert the word depends. And see what makes more sense when you're reading it to someone. Should I say age depends on height? Or should I say height depends on age? What would make more sense for you to say? What would more people agree on just from a common sense standpoint? Your age does not always depend on your height. More often, your height goes up as you age. So height depends on the age you're at. Obviously, a 1-year-old, just in, normal circumstances, a 1-year-old is not going to be the same height as a 7-year-old. So your height increases as you age. Height depends on age. So this would be the more sensible way to say it. And in that case, once you decide what's the more sensible way to say it, what makes sense, the variable that comes before the word depends, look at where the word depends is. One of the variables will come before it, one of the variables will come after it. The one that comes before it, just like it's being said, height depends on age. This is the dependent variable, and this is the independent variable. So in this particular scenario, height is the dependent variable, and age, what comes after the word depends, is the independent variable. Oops, I wrote G twice. Okay, so that's that particular one. Okay, let's read this next problem. Your score on a test, that's something that could represent a variable. So that's a variable right there. Score on a test can change. It can come out to be 50%, 90%, 100%. And the amount of time studying. Okay, so study time. Okay, so I'm going to reword this two different ways. I'm going to reword it as, I'm going to just call this test score. Should I say it this way? Test score depends on study time. Running out of room there. Okay, you could say it that way, where this would be a variable, test score. This is the variable that comes before the word depends, and then you have a variable that comes after depends. I think that sounds right. Test score depends on study time. It typically does. The more you study, the more you change this, the better this comes out. So this depends on this. Even if you were to reword it the other way, it would not make as much sense as what you have right here. Let me move this down a little bit so I can rewrite it the other way. So this is an example. Okay, you could also put it the other way. You could say study time depends on your test score. And I don't think that that makes sense like the first way that we wrote it. Your test score typically is going to be dependent upon how much time you study. So this would be the correct way to write it. Again, the variable that comes before depends is the dependent variable. So let's write that here. Not much room to write here. Test score is the dependent variable, and study time is the independent variable. Okay, one more example down below. Let me try to highlight what the final answers were. This was for the first example. And I used the technique of picking out what the variables were and inserting the word depends and rewriting that statement two different ways, choosing which one makes sense, and then picking out the dependent and the independent variable. For this second example, this was the final answer, and I used the same technique, and I'm going to demonstrate it one more time. Okay, so here is hours worked, that's a variable, and your paycheck is a variable. Hours worked can change from week to week if you're on an hourly type of pay scale, and your paycheck can change each week if you're on an hourly working agreement. So let's see, so number of hours worked depends on your paycheck. Does that make sense? Or does your paycheck depend depends on hours worked? I think the second sentence most definitely makes more sense. Your paycheck, if you're on an hourly pay scale, your paycheck will depend on the number of hours you work. You'll have a larger and larger paycheck depending on if you work more and more hours. So this makes more sense. Again, just look for the word depends, because what comes before it, that is the dependent variable. And this one is the independent variable. Okay, so I just wrote it right here in the sentence. Okay, dependent variable, independent variable. Make sure that you can identify which is which given the problem in words. Okay, another way that I said that you will be asked the question of independent versus dependent variable is when you are given an equation. And I was telling you that independent is where you're putting the values in, and that would be this variable right here. You'd be dumping in different values right here, and what you get for this value depends on what you put in here. So you can put anything you want in here when you're having an equation, always on the side where all the mathematical operators are, where the expression is containing all the mathematical operators. That's where you're inputting your value. And the variable that's all by itself is just waiting for an answer to be created based on what you've done over here. So this is what we call the input or independent variable. And this is what we call the dependent variable. Okay, it has no control over anything other than it's waiting around to see what gets input here. This is known as the input value, but we're trying to identify it as an independent or dependent variable. So yes, it can go by the word input, but it is also considered the independent variable. The dependent variable is the one that is just waiting around to see what happens over here. and that can be also called the output. Okay, so that's just an example of when you're given that type of question in equation form. Okay, then we come to the last part of this section, section 2.2, where we're learning how to solve equations. Okay, we start off in example 1 with our equation solving, where we have variables only on one side and we're trying to isolate that variable. When you're solving an equation, it's like a balanced statement. If you could imagine two beams that were like a balanced scale, and both of the scales are balanced, they're both at the same height. If you add 5 pounds to one scale, you have to add 5 pounds to the other side so that you restore the balance. Well, that's just how an equation is. When it starts off, it's balanced on both sides. It may not look balanced, but it is balanced. So anything that you try to do in an attempt to get this x by itself, you must do to the other side as well to keep it balanced throughout the whole problem, to keep it equivalent to what it started as. So we're going to be trying to isolate this x variable. I just want to warn you that there's a certain order of steps that you should carry out when solving an equation, and that is to always get rid of the coefficient as the very last step. Anything that is either added or subtracted to the variable, you should get rid of that first. Now you're going to make things move from side to side by performing what's called inverse operations, which really just mean perform the opposite operation to get that term to go away from a particular side to get it to cancel. So this is a positive 2. The opposite of a positive 2 is negative 2. That's the same thing as subtracting 2. Remember that whatever you do to one side of the equation, the equal side represents the two sides. So whatever you do to the left side, also do to the right side. On one side, the 2's will cancel, getting this x to being closer to being by itself. Now it doesn't have the 2. And over here you have a 12. Okay, then the very last thing you're going to do is get rid of that coefficient, which will always present as a multiplier. So this is being multiplied. Well, in most cases, they can make it look as though it's division, but that could also be termed as multiplication, but I will show you that when that comes. This is x multiplied by 3, and if this is a multiplier and you want to get rid of it, the opposite of multiplying is to divide. That will undo any type of multiplication. To divide by the very same number has to have exactly the same sign and everything. So if you're going to divide by 3 on this side, you have to divide by 3 on this side. Let me just make room for my answer. Okay, so here the 3's would cancel. 3 divided by 3 is 1, so you end up with just 1x. Drop down your equal sign at that point, and you can keep dropping it down at each stage if you want. I just drew this line here to establish a left from a right. And 12 divided by 3 is 4. If you'd like to check your answer, you can always go in and do that, and in fact you should have that skill, where you would take the original equation, leave a blank spot where any x's are, and then dump in your supposed solution and see if it checks out. Like here you would have 2 plus 12, that most definitely is 14. It checks out because you get the same number on both sides. Please don't give this number as your answer. This would be your final solution. We were just verifying whether or not it was correct. Okay, moving to the next page. Okay, and next page we have various types of examples where you're going to be solving for x. I'm going to do 2 and 5 at the same time just because they're the same type of problem. These are both proportions where you have one fraction on each side. Like I know this 5 doesn't look like a fraction, but of course it can be written as 1. So if you have no more than one fraction, no extra terms besides a fraction, one fraction on each side, you can cross multiply your way to the solution. That'll get you started. It'll at least get rid of the fraction. So you're going to cross multiply right across that equal sign, multiplying the numerator here times the denominator here. That's a numerator, that's a denominator. Make sure that's what you're multiplying, whether you're going this way or that way. So 5x times 1 is 5x. I'll put that right here. Now go the opposite way. Again, multiplying a numerator times a denominator, and that would be 20. Then pop that equal sign right in between the two products that you just got. That's a product when you're multiplying, and here was another product. And then that's what you're going to be solving now. So now at least you have an equation that's not a fraction. Cross multiplying will get rid of the fractions when you're presented with a proportion. To solve this, it's only one step. All you need to do is get rid of this multiplier of 5. We get rid of multipliers by dividing. This will cancel, leaving you with x equal to 4. Supposedly that is the answer. I'm going to check it just so you practice your checking skills. It started off as 5x divided by 4 is equal to 5. Let's see if that checks out when I put my answer in there. It does, because you could go 20 divided by 4, or you can just say, hey, these cancel out, leaving you with just 5. So that checks out, and your actual solution was x equal to 4. Okay, if I also do number 5, this is also a proportion. You have a fraction here and a fraction here. And again, all you have to do in this particular case to get rid of the fractions is to just cross multiply. So you can go 5 times 14, which is 70. And then you can go this way and you have 7x. 7 times x is 7x, and then put that equal sign right between them, and then you'll continue solving that because this is equivalent to what you started with. Okay, so we're going to have 70 minus 7, or 70 is equal to 7x, and we're going to just try and get the x by itself. Whether the x is on the left or on the right, it doesn't matter. You're just trying to get rid of whatever is with it, whatever is with the x. We have a multiplier with the x. So we're going to divide that multiplier right off of the x so that it will be isolated. That's what we consider solving for x. And whatever I do to the left or to the right, I'm also going to do to the left. So here the 7's would cancel, leaving you with x. 70 divided by 7 is 10. Okay, I'll check them every so often just so you have that skill. But you can, check any of these. Okay, so x equal to 10 is the solution for that problem. And then let's go on. We'll do number 3. Okay, so in problem number 3, we have 3x plus 2x is equal to 5. So the concept here is that you have variables in more than one spot. So if you're on any side, whether it's the left side or the right side, you want to combine variables. This is called combining like terms. So it's 3x plus 2x, 5x. Clean up each side. On this side, there's no like terms because there's only one term, and then go into your solving steps. This x is being multiplied by 5, so to make that 5 go away, we divide it right off of the x. Make sure to do the same thing on both sides, and you get x is equal to 1. I'll check this one. So you're getting some practice with checking. So it's 3x plus 2x is equal to 5. I believe my answer is 1, but I'm checking it right now. So 3 times 1 is 3, 2 times 1 is 2, and yes, it does check out because we get the same number, same sign on both sides. So x equal to 1 was the correct solution. Okay, moving to number 4. And in this particular problem, let's see, we have variables on both sides. So here we had them on the same side, and we practiced the concept of combining like terms. Here, we don't have like terms on either one of the sides. We have an x term and then something that doesn't contain x. Same situation happening over here, but we do need to get all the x's on the same side. And that's your choice. You can either bring them all over here or you can bring them all over here. Get all your x's on the same side. Okay, so if I was going to try and get this negative 8x over here, I'd want it to go away from the right side and appear on the left side. You make things cancel or move from side to side by just using the inverse. So instead of negative 8x, positive 8x. That's the same thing as adding 8x. If you're going to do that to this side, you must do it to this side. So in essence, also what you're doing when you do that, you're just making things move from one side to the next. So this goes away. You're left with 26. And then over here, 7 plus 8 is 15x. You also have a minus 4. And then you're ready for the next step. So far what you've done is you've moved this negative 8x to this side. Once it moved to this side, it appeared as a positive 8x. Okay, next we are still looking at 2 additional steps in order to get this by itself. First, we're going to move the negative 4 by adding 4. That'll make it cancel on this side and make it reappear on the other side with the opposite sign. So now we have 30 on the right hand side, we have a 15x on the left, and one more step to go. Always removing that coefficient as the last step. So we're going to take this multiplier of 15 and divide it right off of the x. Make sure to do the same thing on both sides, division by 15, which leaves you with a 2. Okay, so I've demonstrated how to solve several equations, and I've also showed you how to check. I did that for about 3 of the problems, just so you could have some practice checking your answers. And then next we get to a formula. We have more than one variable, and we're going to evaluate this expression for different values of x and y. So here, notice that you have an expression. Oh, actually, I don't want to call this a formula. This is just an expression because it doesn't have an equal sign on it. So let me use the correct terminology. So this is an expression containing more than one variable. They're telling you what to plug in for those variables so that you can actually evaluate the value. So this expression says 3 times x minus 4 times y minus 8. I'm leaving blank spots for x and y because they've told us what to put in for x and what to put in for y. So we're putting in 2 for x, 3 for y. And then when you evaluate this, you have to obey PEMDAS. PEMDAS is just a saying that helps you memorize the order in which to perform the operations. It says, if you have a parenthesis, that is top priority, but we're talking about a parenthesis where there are multiple operations to do inside, more than one operation to do inside the parenthesis. You don't have anything like that. You're just using this as a way to show, hey, I'm inserting the 2 for x. If you had looked in here and there was addition and multiplication to do, more than one thing, the parentheses would direct you to go inside the parentheses and do those things first. So that does not apply in this problem. Next would be exponents, where you see like powers. You would have to do that as the second most important thing. So this is a top priority. This has second priority. There's no exponents here. These two have equal priority. So you would pass through the equation left to right always and do any and all multiplication and division in the order that they're presented. We do have that. We do have some multiplication. We don't have any addition, but we have multiplication. So we have this multiplication right here. That would be 6. We have this multiplication right there. That would be 12. Drop down the minus sign between those two products, as they're called. Multiplication, same thing as product, and bring down that minus 8. Any addition and subtraction that you have, in the problem has last priority. It is the fourth thing that you will do. You must do them in this order. Again, PEMDAS has a strict order in which you must perform the operations, and you have to do them in that order or you get a different answer. So now we're going to do subtraction. It's going to be 6 minus 12, which is negative 6. Just look at it left to right, and then we're also going to combine the negative 8. And when you combine these two numbers, you get negative 14. And that's your final answer. Okay, make sure that when you're doing the subtraction, you're moving left to right. Don't start back here, because notice that if you had done it going this way, doing these two first, 12 minus 8, you would have gotten 4. If you had tackled the subtraction going right to left, so make sure you would have gotten 4, and then it would have been 6 minus 4 is 2. See how you don't get the same answer? So you want to make sure that you're moving left to right as you perform the subtraction, doing whichever subtraction you hit first. We hit this one first. We got a negative 6, and then we took the negative 6 and combined it with the remaining number, which was negative 8, to get negative 14. So be careful with that. Okay, I believe that was the last problem, so that concludes section 2.2 and 2.1, all in the same video.